Here's an example. When two 6-sided dice are tossed, there are 36 possible outcomes as shown. Where did this 36 come from? Remember, from the fundamental counting principle. Here's dice 1 and here's die 2. There are 6 different ways in which this die can fall and 6 different ways in which this die can fall. So if we multiply those 2 different ways in which they can happen, I'll get 36 different possibilities. Okay? And that's where this 36 comes from. I could get a 1 and a 1, a 1 and 2, a 1 and a 3, and so forth. Okay? 36 different possibilities. Letter A says, what's the probability that the sum is not 8 when I roll the pair of dice? What is the probability that the sum is not 8? Now we have 2 ways of doing this. We can use it. You could do the normal way. It's counting all the pairs that do not add to 8. Or we can use the complement. We're going to do both. Okay? If I do it the normal way, the probability that it's not 8, let's look for all the dice that add to 8. Here's one. 5 plus 3, 6 plus 2, 4 plus 4, 5 plus 3, 6 plus 2. Okay? So I would have to count all the other dice except these 5. And since I know there's a total of 36, then that would equal, if I would count all the other pairs, I would count up to 31. Okay, you would start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. 31 out of 36 is the probability that the sum is not 8. Now, let's say I want to work with the complement of not 8. The probability of the complement of event A would be finding the probability that it is 8, that the sum is 8. The probability that the sum is 8. Sum is not 8 in this case. So if I look for the complement, which is find the probability that the sum is 8, that would be 5 out of 36. Now, how does this help me find the probability that they're asking for? Well, simply, I can say that the probability that the sum is not 8 is equal to 1 minus the probability that the sum is 8, which is equal to 1 minus 5 over 36, which is 36 over 36 minus 5 over 36, equal to 31 over 36, which is the same answer we found doing it the normal way, counting the ones that were not. So notice how the different approaches, okay? In this case, it seems easier to just look for the complement, and with the information on the complement, I subtract that from 1, and I get the probability of the event that I had originally been looking for. Okay? For letter B, we're looking for the probability that the sum is greater than or equal to 4. Let me change colors so we can circle the sums that are greater than or equal to 4. So here's 4. This is equal to 4. This is equal to 4, and this is equal to 4. And I'm looking for all the sums that are greater than or equal to 4. So Doing it the usual way, I would have to count these 3 plus all of these that will give me a sum that's greater than 4. Okay, so I would have to count those 3 plus all the other ones whose sum is greater than 4. So that would be all of these. Let me just draw a box of all the pairs whose sum is greater than or equal to 4. And here they are, all of these. So if I wanted to count all of these, I would get 33, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So for letter B, the probability that the sum is greater than or equal to 4 is 33 out of 36. The other approach of doing this is finding the probability of the complement of A, which is the other things that are not greater than or equal to 4. That would be equal to finding the probability of the sum being less than 4. If I find the probability of the sum being less than 4, then I can subtract that amount from 1 and find the probability of the sum greater than or equal to 4 if we work with complements. Okay, so the complement in this case is finding the probability that the sum is less than 4. So the probability that the sum is less than 4 would be these 3 here are the only 3 whose sum is less than 4. So this probability would equal 3 out of 36. Now, remember, this is the complement. I'm not looking for the complement. I'm looking for the probability that the sum is greater than or equal to 4. So the probability that the sum is greater than or equal to 4 will equal 1 minus the probability of the complement. And the complement is that the sum is less than 4. And we found that that would be 3 out of 36. And, whoops, sorry about that. Let's go back. And that is equal to 36 over 36 minus 3 over 36, which is equal to 33 over 36. I'm running out of room here. I'm sorry about that. Okay, so you get the same answer as doing it this way. Okay, what is quicker for you? What do you think will work better for you? You choose. You can choose to work with the complement, or you can choose to just count all of these, which is actually subtracting 36 from the 3 that are left over. So unconsciously, we're using the complement. We're just not stating it. It's a tool that you can use whenever you need to. When it's too hard to find the actual probability they're asking you for, then you can go ahead and do the complement. I hope this helps, and I'll see you in the next video. We'll have more examples on the complement of A.